All right, so how do you know what to start with? Look at this problem. It says, what mass of potassium phosphate is required to prepare 4 liters of a 1.5 molar solution? They gave you 2 numbers, right? But you need to know which number to start with, all right? Unlike limiting reaction and stoichiometry, you're not going to use both of them and then, do 2 separate problems. You're going to do one problem with both of these numbers in it, okay? Well, let's look at the hint here. It says, if you are asked to find 1 unit, start with 1 unit. Okay, so let's check this out. 4.0 liters. That looks like this, right? And then this 1.50 molar, what did the big M stand for? It equals what? Yeah, moles per liter. So how many units does this one have? Yeah, 2. Is everybody cool with that? Moles, liters, 2 things there. How many units does the 4.00 have? 1 unit. All right. And what are we looking for? What's mass? Yeah, it's related to moles, right? But what are we usually converted into if we're talking about mass? Yeah, we're going to talk about grams for this. And grams is how many units? 1. Even though it's plural, it's 1 unit. All right? So if we look at this rule, it says if you're asked to find 1 unit, you're going to start with 1 unit. All right? We're asked to find 1 unit, right? We're looking for grams. So out of the 2 things that are given, which of these also has 1 unit? Yeah, the 4 liters. So we're going to start with that. All right, 4 liters. 4 liters of what? It's 4 liters of water. All right. Okay, so we started with this. Now, here's the new thing we're going to do. What's going to go on the bottom? No, just tell me unit-wise. Liters, right? Okay. Are we talking about gases here? No. So we're not talking 22.4 liters, right? We're not talking about gases. Everything here is going to be aqueous, right? It's going to be some kind of solid dissolved in liquid water, all right? So we're going to have liters here, all right? If you look up here, does anything else besides the 4 have liters in it? Yeah, look at that. Moles over liters, right? So we're going to take this and plug it in. So the 1.5 is on top. Moles. All right, 1.5 moles of, we need to figure out the units for this. Usually the units are the easy part. But what do you think it's moles of? Exactly. Good guess. K3PO4. All right, where did I get that from? Well, that's the solute in this problem, right? So it's always the solute over the solvent. And with the liters, we don't have to write water. We could, but it's always just going to be assumed that it's water unless they tell you something different, okay? How many liters? Yeah, it didn't say, so we just put 1, all right? So this is what they told us right here. Look at all the information you could kind of figure out just from them writing 1.5 and a big M, all right? All that stuff is what that means. Is everybody cool with that? Okay. Remember how we're looking for grams? Now, what would you do? Yeah, exactly. The liters cancel out, and as you just said, we go moles to grams, right? So what unit's going to be on the bottom? All right, moles, K3PO4, good. And then what's going to go on the top? Grams, K3PO4. All right, where do we get our numbers from? Yeah, exactly, periodic table, molecular mass. Okay, so we get our molecular mass of 212.27, good. And then when we do the math for this, what do we get as our answer? 1270. Okay, 1270, all right, 3 sig figs, right? 1270 is good, okay. Let's talk about what gets canceled out. Moles get canceled out, and then we have grams of K3PO4. All right, is everybody cool with that? Okay, let's talk about what this actually means. Because this chapter is kind of like the one chapter where we're doing like this exact same thing in lab, okay? Let's say we wanted to actually make this solution, all right? How much stuff would we measure out? What would we measure? Give me something. Tiffany?
4 liters.
We need 4 liters, right? So we know we need 4 liters. What else? Of what? Yeah, 4 liters of water, good. And then what are we going to put in the 4 liters of water? Yeah, we're going to need 1,270 grams of potassium phosphate, all right? And so in lab, we'll talk about the proper techniques on how to actually combine them. Because if you think about it, this is a large amount of this, right? It's a lot. It's going to take up space, right? So I'm going to show you that you actually add this in first to figure out, like, you know, because it's going to take up some space. And then you bring this up to 4 liters. And we have a special flask we'll use for it. It's called a volumetric flask. We'll go over all that. All right?